Okay, for number 4, it says Selena has 8 quarters, 5 dimes, and 3 nickels in her pocket, which is a total of 16 coins. If one coin is selected at random, what is the probability that it will not be a quarter? So the probability that it is not a quarter. Remember, the bottom number is the total number of coins in her pocket. The top number is the ones that satisfy what's in the parentheses. So the ones that are not quarters, there are 8 of those, 5 dimes and 3 nickels. So the probability that it's not a quarter is 1/2. You always reduce your fraction. So the answer is D. Number 5 says triangle ABC is similar to triangle JKL. So we have 2 triangles, they're similar. Remember, in geometry you don't necessarily go by how your triangles look. It says triangle ABC, triangle ABC is similar to triangle JKL. We have to draw our triangles with corresponding sides. AB corresponds to JK. So since I put AB like this, I'm going to put JK like this, and L. Okay, it says AB equals 9 and JK equals 15. And the area of triangle JKL is 125 squared units. Wants us to find the area of triangle ABC. Before we do that, we need to find the scale factor. Similar figures have scale factors. One is scaled larger than the other one, or vice versa, smaller than the other one. So the way you find the scale factor is you create a fraction with the similar or the corresponding sides. So the sides that correspond to each other, triangle, AB and JK. So I'm going to create a fraction, 9/15, AB over JK. And I'm going to reduce that fraction. That means triangle ABC is 3/5 the size of triangle JKL. So we want to know the area of triangle ABC. When you are talking about the areas of similar triangles, you use the scale factor, but it is squared. So 3/5 squared times 125. Squaring 3/5, 3 squared is 9, 5 squared is 25. When you multiply 9/25 by 125, you get 45 units squared. So the answer is E. Now, when you're talking about the perimeter of similar figures, you don't square the scale factor, you just use the scale factor as is. Number 6 says factor 9x squared minus 30x plus 25. My suggestion is for you to first see if this is a perfect square trinomial. The hint to me that it might possibly be is the fact that that middle term is even and that 9 and 25 are both squares. The way you see if it is a perfect square trinomial is you half the middle term, so 30 divided by 2 is 15. You square root 9, and you square root 25. This is just to check to see if it is a perfect square trinomial. If I multiply 3 and 5, I do get 15. So this is a perfect square trinomial. And the way it factors, you'll only have one set of parentheses, and it's going to square the square root of 9x squared, which is 3x, goes in the first position of the parentheses, and the square root of 25 is 5, and it goes in the second position in the parentheses. Since we got a negative 30x in the middle, I have to have a negative or a minus in the parentheses. Now let me explain to you why this created a perfect square trinomial. 3x minus 5 squared means 3x minus 5 times 3x minus 5. 3x minus 5 times itself. Distribute 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. Negative 5 times 3x is negative 15x. And negative 5 times negative 5 is positive 25. Now, since the 3x's were the same in both parentheses, they got squared. And since the 5's were the same in both parentheses, they got squared. And this right here, when we combine them, that's where we got twice to get the middle. Okay, number 7 says, which of the following equations represents a line that has a slope of 3 and passes through the point at -4, -1. Okay, so you have two ways to work it, and I will work it both ways. You can use what's called point slope form, and it is y minus y1 equals m times x minus x1. And the y1 and the x1 are the ones that you'll change with the coordinates inside the parentheses. M is the slope. The y and the x stay y and x. So I'm going to change this y1 to -1, so it's y minus that y1. I'm going to change m to 3, and I'm going to change x1 to -4. Now you have to remember that this minus is in the formula, and this minus is in the formula, no matter what y1 and x1 are. So this changes to y plus 1 equals 3 times x plus 4. Distribute, and you get y plus 1 equals 3x plus 12. We want to write this in standard form, so I want the 3x on the other side, so I'm going to subtract 3x, move 3x over, so that gives me -3x plus y plus 1 equals 12. Then move the 1 over. So you have -3x plus y equals 11. Now if you look at the answers, you have a C, B, and D all have a 3x, but there's a positive 3x. None of them are -3x. So in order to change that -3x into a positive 3x, technically I'm going to multiply everything by -1, which would give me 3x minus y equals -11, which means the answer is B. The other way you can do that is by using the slope intercept form, y equals mx plus b. In this case, we don't know what b is, but we know what y, m, and x are. So I'm going to remove the y, and I'm going to change that to -1. I'm going to change m to 3 and x to -4. And whenever I solve this, that'll give me b. 3 times negative 4 is negative 12. Add 12 to both sides. So B is 11, which means if I write my equation, y equals 3x plus 11, then I have the same thing that I had before. I'm going to subtract 3x, which gives me negative 3x plus y equals 11. And I have to end up multiplying all the way through by negative 1 again. And you can see you get the exact same thing.